Okay, we have another integral here today from MIT 2019, problem 16. We have the integral from 0 to pi over 2, sine x over sine x plus pi over 4 dx. Okay, the first thing I want to deal with, I don't like having x plus pi over 4 as the angle, so I want to clean this up. Let's rewrite this just using the different angle formula for sine. So numerator stays the same. This is going to be sine x. Then breaking this out with the formula for this, we're going to have sine x plus cosine of the second thing. So it's going to be cosine pi over 4. And then for the second part, we just switch it. We have cosine x sine pi over 4. But now at pi over 4, the value for cosine and the value for sine is the same thing. This is just going to be 1 over square root of 2. So what I can do is factor this out of the denominator and then flip it, bring it into the numerator. So what I can do is bring a square root of 2 out front of the integral. And then this whole thing will kind of simplify now. Numerator is still sine x. But with this and this gone, now the denominator is just sine x plus cosine x. And so I think what I want to do on this is let's just use King's principle on it. So it tells us if we have an integral from a to b of f of x, what we can do is we can rewrite this as f of b plus a minus x. The reason I want to do this is because the b plus a minus x, we add the bounds together, we get pi over 2. So this becomes pi over 2 minus x. So when we plug that in, we're going to have complementary angle formula happening, because for sine pi over 2 minus x, when we do it in the numerator there, this becomes cosine. And then when we do it for cosine, we just get back sine. So let's see what happens when we use the formula. The bounds are going to stay the same, right? We still have the same a to b. So we have 0, pi over 2. Sine x, when you plug this in, we're going to get back cosine x. Same thing for this one. This one becomes a cosine x. And then here, this is going to become sine x. And then here's the payoff. If we put a label on these, everything, we'll call it I. And then if we just add these two things together, now we've got two copies of the integral. We have 2i. But when we do it, now we've got the same bounds. We get the same denominator. I just have this in a different order. So this is going to become pi over 2, 0, same denominator, sine x plus cos x. Add the numerators, again, sine x plus cos x. But this is going to cancel with this. We're just integrating 1. Do this out. We still have the square root of 2 in front. Integral of 1, that's just going to be x evaluated from 0 to pi over 2. That's just going to be pi over 2. But the one thing we need to remember, we're dealing with two copies. So let's get rid of that. Divide by 2 over here. And for the final solution of this, we just get square root of 2 pi over 4. Okay, there you go. Good problem from MIT 2019. Thanks everyone for watching. Have a good day.